What are some other use cases?
Yeah. So I'm happy to jump into that part if you'd like, actually.
No, no,
I have
no.
some
Let's hold
strengths
off.
and
Let's hold.
Actually, no,
Let's.
that's a good heading there. Strengths and weaknesses. Let's go
All
over
right.
that.
All right, but let's not jump into immediate because the next session I think we'll do is here's a practical example of applying some of this stuff. So
Okay.
Yeah, absolutely. And I think if we have time today, I'll try to give the like high level quick taxonomy teaser to kind of to try to provide a groundwork for that. But then yeah, before that, let's definitely dive into the machine learning strengths and weaknesses. All right. And I think we've talked about a lot of these. So strengths, machine learning is good at performing tasks at scale. So again, scaling human intuition in order to do something at scale may be slightly less quality than a human would have done it, but at scale. Another one is optimizing complex systems. And this is related to this idea of reinforcement learning that I mentioned before, really taking in data and other information about your system and being able to provide some notion of, what are the actions you should take and really learn that in a really nuanced way. Another one is creating derived data. So taking, for example, large amounts of satellite imagery and really trying to extract from that, where are the solar panels in the image, or trying to take large amounts of text documents and really extract from that, what are the policy commonalities in different policy texts that we see that enable us to, understand what those patterns are to make new policy, or analyze large amounts of patent data to understand what the patterns are. So really taking large and raw amounts of data and trying to distill it some way into an actionable insight. And then another is, dealing with different kinds of data sources. So for example, forecasting solar power output, which is an example I brought up a few times, it's something that we've been doing forever, right? First using rule-based techniques where you basically write down, is it a holiday? Is it, what day is it? And, I guess a holiday doesn't matter for solar power output as much as say a power demand, but you get the idea. You write down some kinds of rules. And you predict these things, or you can use physical numerical weather prediction models to come up with what is the solar irradiation going to look like somewhere, and what does that mean for solar power output. But what machine learning is really good at is taking in multiple types of data and really learning to analyze patterns among that. So you could have a machine learning algorithm that takes in historical weather data, but also takes in the outputs of a numerical weather prediction model. And it also takes in images of clouds moving overhead, your solar panels, and really analyzes all of that together in order to provide some kind of prediction. So this idea of just dealing with many different types of data sources and finding really powerful correlations between them is something machine learning is good at.